Alrighty, we're going to talk about factoring by grouping. This is the last little piece of this half of this unit. And let's see how it goes here. So factoring by grouping is not that hard, but it does require some thought. All right. And it's going to look very familiar to you because we did something similar to this when we split the middle term back in the first unit that we ever did. So on these kind of problems, you'll notice you've got four terms. Now, we've done a lot of different factoring. We've done a lot of factoring that starts with just an x squared term, but not with a cubic term. So what you want to do on these questions is the first thing you want to do is you want to split this thing in half. And that should be a little visual cue to you as to how we worked through these problems when we did them the first time with split the middle term. Yes. So what we want to do is we want to look at the first half and figure out what is a greatest common factor of those two terms. What do they both share? Well, 3 and 7 won't divide by anything but 1. And then they both have at least an x squared in them. So what we did is we said, okay, well, we're going to factor out a 1x squared and see what's left over. So if we divide out x squared on both of these terms, we're left with a 3 and an x on the first term, and you're left with a plus 7 on the second. Does that look familiar to you? All right, and then what we're going to have to do is do the same thing here. We're doing a greatest common factor of negative 15 and negative 35. So what we talked about when we did one of these problems earlier was whatever that middle sign is, bring it down, and then figure out what number you need. So technically, 5 is the greatest common factor, but we're going to use negative 5 because that's negative. All right, you only need to do that on the second term when and if that happens. All right, so if we divide both of these by negative 5, we're going to find that we get a 3x and then plus 7 for this half. Okay, so what we talked about was when you do one of these problems, you're looking for this common factor that both halves of your problem share. And so that is your first factor. And then what's the other one? It's the leftovers is what I called them. So whatever's left over after you remove that, that is your other factor. So usually what you need to do is double check and make sure that you can't do anything else with what you have, but this is good. You can't reduce this anymore. You can't factor anything else out of this. So that's your answer for that one. All right. Sometimes you will have chances where you can do more. I don't know if I've got one of those here for you today or not, but I'll try to find one of those hopefully and upload it for you. Same thing on this problem, right? We're going to divide it in half and then see what the greatest common factor of these two terms is. 24 and 16 both divide by 2. They also both divide by 4, but the greatest common factor, the highest number that both of them can be divided by would definitely be an 8. So you want to factor out an 8 for the coefficient, and then we're taking out x squared because both of them have at least 2 x's. So if you want to, you can think about what happens if I divide this out of both of these terms. So 24 divided by 8 would be 3, and we're still going to have that x left over. Bring down your minus sign. 16 divided by 8 would be 2. So there's your first factor and what's left over when you take it out. All right, same thing over here. That's a minus, so we're going to bring down that sign no matter what. What's the highest number that divides into 9 and 6? That would be 3. Now, we're dividing it out. We're not subtracting it, so keep that in mind. So what's left over when we do that? Well, and remember, we're really dividing out a negative 3. So that would be 3x for the first time, and then positive 6 divided by negative 3 is a negative 2. What do you notice about your parentheses? Well, you've got two factors that are the same. So that's good news. That means your first factor for your answer is 3x minus 2. The second one is 8x squared minus 3, which is the leftovers. Again, you always want to double check when you get here and make sure you can't do anything else with this answer. What am I talking about when I say that? Let me give you an example over here. Let me just kind of show you a what if. So what if this happened, okay? So let's say you had your answer was x plus 3, and then you had something like x squared minus 25. Right? It's possible. X plus 3, you can't touch that, but x squared minus 25, what do you call that? That is a difference of squares. And so if that happens, you are obligated to factor this thing out completely. So I would expect you to bring down your x plus 3, and then divide this up into x plus 5 and x minus 5. So you can have that happen. It doesn't happen all the time, but you always need to double check to make sure that you have factored completely. And that, after all, is the instructions for how to do these problems.